Okay, so 1j from 12.5, we've got a function x is equal to 8x cubed minus 36x squared plus 54x minus 27. Okay, so we're looking at a function here, we're finding the roots, we're seeing if there's any multiple roots. First thing we want to do when we're solving this is to try and test specific values to see if we can get something that will eventually work. So I'm going to try f1, which gives me 8 times 1 cubed minus 36 times 1 squared plus 54 minus 27. That is 8 minus 36 is sorry, minus 28. That's not going to work. It is close, but it doesn't work. So what we're going to do really is at this point guess, check and refine to see if we can get a better value. So chuck in 2. When we do that, typically it's quickest going to be done with the calculator. So I'll see if I can quickly get an answer for us here. 2 won't work. I'm going to try 3 because it's a factor of 27. Okay, 3 doesn't work, but we might be able to try minus 3. It doesn't work either. Okay, so there's no, at this point, any clear solution to this. There's no way to divide, so I'm going to pause the recording. Okay, so I haven't been able to find anything yet. The reason I think is because that this one's non-monic, so it has an 8 out the front, which is preventing us from being able to find a simple solution to it. So what I'm going to do is something interesting just to try it out to see if it works. I'm going to find f-x, and the reason is because remember when you have a multiple root, you have the same root for the gradient as well as for the original function. So you can see here that this gradient function, which will have, if it's a multiple root, it will have a root at the same place as f-x. It's pretty gnarly. It's got big numbers, so we're going to factorize. You can take definitely a 2 out of all of that. So we get 12x squared minus 36x plus 27. Okay, and actually, in fact, you can take another 3 out, which means all of those could have been divided by 6 in the first place. So that is better as written as 6 outside of 4x squared minus 12x plus 9. Okay, so we've got something more manageable here. That means if we can find a root for 4x squared minus 12x plus 9, it'll hopefully be at the same place. So let's solve that one. So for f-x equals 0, we've got 4x squared minus 12x plus 9 equals 0. Okay, so let's see what we get here. We've got PSFing it. We've got 36 for the product, or plus 36. For the sum, we've got negative 12. And for factors, to do that, we can do 6 and 6. It's interesting. Okay, so we've got minus 6 minus 6, which means we've got 4x squared minus 6x minus 6x plus 9. Factor that out, we get 3x outside of 2x minus 2. That's not right. 2x minus 3, and sorry, not there. We get minus 3 outside of 2x minus 3. Okay, so we've got a pair. It's interesting. We've got another one there. So we've got 3x minus 3 outside of 2x minus 3. Okay, now one of these is going to be a root of the original one. So we can test both of these. For this one to be correct, we need x equals to 1, and we tried x equals to 1 and it didn't work, so that's a cross, which means the other one is 3 on 2. So we'll test f3 on 2 to see if that's our multiple root, and subbing that in, we get 8 times 3 on 2 cubed minus 36 times 3 on 2 squared plus 54 times 3 on 2 minus 27. Hopefully that gives us the number that we're looking for. So checking that out. And that does go to 0. And so that tells us that this is actually our initial root of this one. And as you can see, instead of putting it in as x minus 3 on 2, you can put it in as 2x minus 3. So when I do my long division, I'm going to do 2x minus 3 outside of all of this stuff. And my first factor is going to be 4x squared, rather, 4x squared. So 4x squared times 2x is 8x cubed, minus 12x squared. Do my subtraction, and I get negative 24x squared, because the minus minus adds. Bring down 54x, and I get I'm going to times that now by negative 12x, negative 24x squared, plus 36x. Subtract that all out, and I get 18x. Bring down the minus 27, times both by 9, and it cancels. So that means now all I have to do is simplify 4x squared minus 12x plus 9 to find out where this goes. That actually looks a lot like a perfect square to me. So I think that's actually 2x minus 3 squared. So I'm going to assume it is and then check if it works. So 2x times 2x is 4x squared, which is good. 2x times minus 3x is negative 6x doubled is negative 12x, so that's good, and plus 9. Now that means that function x is just equal to 12x minus 3 cubed, because there's 3 of them. Therefore, it has a triple root, because all 3 of them are in the same place, and it has a triple root at x is equal to 3 on 2. Okay, so I found that by going back on this, checking f dash x, because I know that if it has a multiple root, it has it at the same place. I found the one that was there, and I went back to the original function and subbed in to minimize it down to find what the other roots were. That's all.